Okay, this last problem says an object is launched at 19.6 meters per second, and the ms is meters per second, from a 58.8 meter tall platform. The equation for the object's height, s, at time t seconds after launch is s of t equals negative 4.9 t squared plus 19.6 t plus 58.8, where s is in meters. And then when does the object strike the ground? Well, this is another one that, I like visual, so I like to see what I'm looking at. So I'm going to draw a little x and y graph. And so it's my x, it says the equation for the object's height. So this means we're dealing with height again. Okay. Object's height at time t. So this is time. Okay, so this is t, and our height is s. So an object is launched at 19.6 meters per second from a 58.8 meter tall platform. So this platform, 58.8 meters tall, so this item is launched off of it. So let's launch this item off of it. Okay, so this is the meters. When does the object strike the ground? So we need to find this point right here, okay? But it's asking us when, so we're really only concerned with our x. But if we go ahead and find the point, it's easier because really that point, it'd be 0 for a height. So really, if it's 0 for a height, we're looking for an x-intercept, okay? So if it gives us an equation, gives us our function right here, s of t. So if s of t, negative 4.9 t squared plus 19.6 t plus 58.8, it gives us our equation. So we're wanting to know when it hits the ground. So that's going to be something and 0. So it's going to be our x-intercepts. Well, how do we find that? We plug in 0 for y. What is our y? Our y is s of t, because remember f of x or anything that you see in this format, that's going to actually be y equals. So we can say y equals. Well, really here, y equals 0. So instead of y equals, we can actually say 0 equals, because we can plug in our 0. So now we can put it into the quadratic formula. We have our a, our b, and our c. So when we put it into the formula, we have negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Okay, so our b is 19.6. 19.6. Our a is negative 4.9. And our c is 58.8. And our a, again, is negative 4.9. So let's go ahead and work it out. So we have x equals negative 19.6 plus or minus square root 19.6 squared is 384.16. Then we have negative 4 times 4.9 times 58.8, and we get a positive 1152.48. Okay. And then we multiply 2 times negative 4.9, we get negative 9.8. Okay. Keep working it out. And then we have 384.16 plus 1152.48. And we get 1536.64 all over negative 9.8. So as we continue to solve this, we're going to get negative 19.6 plus or minus 39.2, because the square root of 1536.64 is 39.2, all over 9.8. So this is where we're going to break off and do our positive and negative answers. So then we have negative 19.6 plus 39.2 all over negative 9.8, and negative 19.6 minus 39.2 all over 9.8, negative 9.8. So these calculations, negative 19.6 plus 39.2 is 19.6, divided by negative 9.8, that'll give us negative 2. And then for the negative side, do those calculations and it'll give us 6. Okay, so our answers are negative 2 and 6. So now, since we're talking about launching an object, we can't really have a negative because we're dealing with real world stuff. So we can't go back in time, and since we're talking about time, this being our x solutions, so we can't have a negative time, so we're going to disregard that one and only have our positive answer. So our positive answer would be 6. So when does the object strike the ground? 6 seconds. I hope this helped. If you have any questions, just let me know.